So what's going on, YouTubers? This is DIY Dan, Saltwater Junkie, and today I'm going to be building a protein skimmer shutdown. The purpose of this is when I do my filters, the protein skimmer I have overactivates like crazy. Another situation I've had happen is my return pump shut down, overfilled by SUMP, caused my protein skimmer to overactivate as well and made a big mess. So let's get to it. Okay, so this is the demonstration here. I've got my extension cord plugged in here and my 12 volt inverter. Alright, this is pretend my skimmer. Okay, this is my on off switch. So I'm going to turn that, it's going to shut down. Okay, turn it back on. If my pump quits, we're going to pretend this is my tank. Pump shuts off, overfills, it's going to shut it down. Alright, and then if I forget to drain my skimmer container and this gets too full, it's going to shut down before I overspill. So real quick, guys, this is a better picture of that bracket I made. And this was some 1/2-inch plastic I had, and then this little piece of acrylic is, and then basically I used plastic screws, and all I did was drill and tap some holes, and I'll show you. The relay I bought at Amazon for like $8. Alright, you want to make sure that it handles at least 10 amps. Now the most expensive piece of this thing for me, and I had bought this a while ago and used it for something else, but is the inverter. Now this was a Best Buy inverter. You can set your different voltages, but what you can also do, which I've done on a couple of my other items I've built, is a lot of your home appliances or calculators or all kinds of stuff will come with an inverter already on it, and the inverters will say how much voltage they produce on the face of the inverter. So that's just another way to save money. So when I crimp, now you are dealing with electricity, so you want to make sure that you crimp these wires good, okay? Now when I do them, I usually, like these two, I put these together, I stripped them back farther than I needed to, and I twisted them together. I twisted the wires together so they're kind of bound together already. Then I put them in, then I crimp it, and you want to make sure you got a good set of crimpers. Don't buy a cheap set of crimpers. Get a nice set. See how wide that is? That's going to give you a good wide crimp, and you can really put some leverage into these things. All right. Now the reason I say that is a nice wide crimp. If you use a real skinny crimper, you can almost cut the wire as you're crimping it. All right. So, and you can do it. It will work. Just be careful with it. And then what I always want to do afterwards is tug on these wires from each side. I can't do it because I'm holding the phone right now, and make sure they don't come out, because a loose connection is going to cause resistance, which is going to cause heat and can cause issues. You know, when you're dealing with electrical, you want to make sure you got a good solid connection. Now these little crimpers don't have any insulation on them, so I use heat shrink, and these are kind of harder to find besides at an electronics store. But you can use the insulated ones you get at Home Depot, but still put some heat shrink over them, just to be safe, just for water protection. So we're going to go ahead and do that real quick. Okay, evenly across there. And then just shrink that down. Alright. So that way you got a nice waterproof seal. Okay guys, so this is my protein skimmer cord. And I just wanted to show you this because this is the other critical to this. You want to make sure the cords you're using are at least the same gauge or bigger than what your skimmer is. So this is a 3 conductor 18 gauge, so you can see it there, 18 AWG. Okay, so this is the appliance cord I'm using. And right here it also see the 18 gauge. That 3 times I believe is how many wires, but 3 times 18 gauge is the critical. Obviously if you have a 3 wire, you need a 3 wire cable. So 18 gauge. Now, like a 20 gauge or a 22 gauge, you know, that's a smaller wire. You never want to do that because you're trying to pull amperage that's made to go through an 18 gauge wire, and you're pulling it through a 20 gauge, which is smaller. It will get hot, it can cause fires, it can cause overheating, it can cause failures, really bad things. So just make sure your cable and your relay can handle the amperage that the protein skimmer needs. All right, so this is my DC wire. So I'm testing it here. See how that's giving me a negative number? So that means I'm reversed. So let me test it this way and show you. Okay, that's giving me correct reading, 12 volts. So that means this wire is my positive and this one is my negative. Stop. Alright guys, so let's go over this wiring diagram. Our 12 volt relay, okay? First we'll go over the AC part. Off of the 110 outlet, we're going to have an extension cord that we talked about. We're going to split into the extension cord and grab a common, which is the big slit on a 110 outlet, and the hot, which is the small vertical slit on an outlet. We're going to split in, cut those wires, and put them to positions 1 and 2 on the relay. And then pins 5 and 6, 5 being the hot and 6 being the common, is the 2 wires coming from that extension cord and going into the female end I put on where the skimmer is going to plug into. Now we're going to use this relay normally closed, which means when it's not activated, it's going to flow from 2 to 6 and 1 to 5, okay? So when nothing's happening with this relay, the electricity is flowing through it. So your skimmer will be running, okay? When it gets activated, which means either my on-off switch gets triggered or one of my level switches triggers, it's going to excite the relay and it will take away those and shut down the skimmer. Now the reason I'm doing this way is because the skimmer's running 24/7, right? There's no point in activating a relay 24 hours a day, 7 days a week, when all we need it for is emergency purposes or maintenance purposes, which is what my switch is for. Okay? So we're only going to activate this relay when we have a problem or when we're maintaining it. Alright, so now we'll talk about the 12 volt side of this thing. Inverter's plugged in. I've got my positive 12 volts coming out to one side. That's coming over and going to pin number 7. Okay? My ground, right off of my 12 volt ground, I actually split off and I put a ground to my on-off maintenance switch, and then I ran one wire because my other 2 sensors are very close to each other, so I ran one wire instead of 2 over, and I teed it over by the sensors, and I put a ground to my SUMP level switch and a ground to my container overfill switch. Okay? Then coming back, I came back and teed it also over this way from both of those switches, and then ran one wire back to pole 8 on the relay. And then there is also a wire running from the other side of my maintenance switch to pole 8 as well. Okay, so now I'm going to explain why we did this way. Since we're exciting the relay, we have to have a ground supplied to it to excite it to disconnect the power. So when this switch is working, when the skimmer is running, right? When the skimmer is running, it's an open circuit, which means it's not making contact. So it's not supplying the ground. When I want to shut the skimmer off, it's going to close the circuit, which is going to connect these, supply the ground, which is going to excite the relay, and it will disconnect the electricity to my skimmer. Okay? Same thing with either of these two level sensors over here. Okay? In the on position, skimmer's on, it's an open circuit. If my return pump fails and the water level starts coming up, it's going to close the circuit and supply the ground. And that's the same thing with this one over here. All right? So it's working a little backwards of what you would normally use a relay, but this is the more efficient way to wire this thing. All right, so this is this thing in reality instead of on a whiteboard, just to show you. That's my extension cord. I split into that appliance cord and went into pins 1 and 2, and then came out on pins 5 and 6 down here. The ground, as I talked about, is just going straight across. That goes over and goes to my where my skimmer plugs in. Okay, the 12 volt from my inverter is right here. The 12 volt positive is going into pin 7. Sorry, that's going into pin 7, and then my ground tees off, goes to my 2 sets of wires here. One of those sets of wires is going to my on-off switch. The other set of wires is going to my 2 level switches, where I teed off the one in the container and my overfill sensor in the tank. And then those grounds are coming back and going into pin 8 on the relay. All right? And the one other thing I was going to show you real quick is, if these switches are working reverse for you, all you have to do is pull this clip off. It comes off by hand. You take the float off, flip it over, and put it back on, and then put the clip back on, and it will work reverse. Just a heads up on that one. So as you can see, my skimmer's running now. I'm going to hit the switch. Shuts the skimmer down. Turn it back on. Alright. Now we'll pretend my pump shuts down. My main return pump shuts down and the tank starts filling up. Level goes up. Skimmer shuts down. Pump comes back on. Water level drops. Skimmer comes back on. And then this is my reservoir with my sensor, and it's going to work the same way. If it overfills, basically tip this over to show you. Skimmer shuts down. I empty it out, put it back on, turns back on. So keep in mind, guys, if you're not doing a storage container like that, you can drill a hole and put that sensor right in the top of your skimmer lid to keep you from overflowing into your tank. Hope you found this helpful. Hope it comes in handy for you, and have a good one. Hopefully see you on the next one. Later.